Hi everyone, welcome back to my channel. I'm Ankit Cloud. In this video, we are going to talk about replica sets in Kubernetes, or in our case, it is AWS EKS. So replica sets. So the main objective of there are four things that are important here when we talk about replica sets. One is high availability and reliability. So this is very important. In order for your application to be highly available and reliable, we need replica sets. So we also need replica sets for scaling the application. For example, let's say currently your application is having 1,000 users, but in future it might go up to 10 lakh users. So in that scenario, right, so you need more and more pods running, and you need a particular logic behind the scaling. So that for that use cases, we will use replica sets. And as I told you, today you are running multiple pods. In order to balance the load between those pods, we will go with load balancing as well. So in our case, we are using AWS. So in AWS, there are different types of load balancer, and it is left to us which load balancer to use. Okay, so we will achieve all of these things by using a concept called as labels and selectors. We will see what are these labels and selectors and what is the use of all the things that we discussed here in a while. So hold on till the very end of this video so that you will get a clear picture of what we are talking about. Okay, firstly, let's go ahead and understand the need of high availability and reliability. So let's assume that understand this. A replica set's purpose is to maintain the stable set of replica pod running at a given point. So for example, we want a stable set of pods running at any given point of time. Let's assume that this is a Kubernetes cluster. Okay, inside this cluster we have a worker node, and we have asked the worker node, or we are asking the cluster to maintain at least 3 pods running at any given point of time. So for example, at that particular point of time, let's assume this pod goes down due to some issues. So in order to go out of this, in order to come out of this loop, if our application crashes or any pod that is dying, a replica set will recreate the pod immediately to ensure the configured number of pods running at any given point of time. As I told you, if this is crashed, it will go ahead and create a new one in order to meet the requirements that you specify. So that is the use of replica set. By going with this concept, we are actually meeting reliability, okay, and high availability. So if you do not know what is reliability and high availability, I have created a separate video on that. You can check that in the AWS playlist. Okay, now let's go ahead and understand particularly about load balancing and why do we need labels and selectors and all those things. Okay, so if I scroll down a bit, so to avoid overloading of the traffic on a single pod, we can use load balancer. As I told you, let's say we have an application and we are running a single pod. For example, if let's say we have a user base of 10,000 now, and let's assume that this pod is able to cater to all the 10,000 users. But in future, this might not work because your user base may increase, and if all the users are going into a single pod to get the details or access the application, that will cause a huge load on that particular pod itself. So to come out of this, what we will do is we will create multiple pods, right? If you create multiple pods, you cannot create a particular IP and provide the IP to the user. So in order to come out of this, what we will do, we will create a service called load balancer, and we will provide the load balancer URL or the IP to the users, and users can access the load balancer IP, and this load balancer will distribute the load to all the pods accordingly. Okay, I hope this concept is clear to you. And Kubernetes provide pod load balancing out of the box using services. We talked about node port service in the previous videos, but load balancer is something that we need to explore in the future, okay, for the pods which are part of the replica set. So now you can ask me, we will have different pods, right? In the cluster, we will have different pods. For example, this application is actually providing user details to the users who are accessing it. But this pod is something else which is not related to this application. Then how do you select the pod to the load balancer, right? So that's where we will have a concept called labels and selectors. Basically, labels and selectors are the key items which ties all the three together. What are all the three things that we are talking? One is pod, okay, other one is replica set, and the service. So in order for this, for example, we will have a pod name for this, right? Let's assume that as AMC pod. So what these labels and selectors will do is, so it will basically select all the pods which are labeled as AMC pod and give it to the replica set and also to the service. Okay, so we will know in detail when we are writing the YAML files for this particular project, and we will try to understand this in a better way later. Okay, so that's the basic idea of what is called as labels and selectors. Now we will talk about scaling as well. So scaling is one of the important terminology. So let's crack that as well. So when load become too much for a number of existing pods, Kubernetes enables us to easily scale up our application, adding additional pods if required. So let's say we have created an application and it is working fine for now. So as I told you, in future we might get more and more users accessing the pods inside the cluster, right? So we will not really know how many pods we need to cater the users base that we have. Instead of creating the pod and keeping it before in hand, which is not a good ideal situation. So what we will do is we will ask the Kubernetes itself, the cluster itself, to scale automatically whenever the resource is required. Whenever there is a throttle on the pods, or whenever there is a resource intensive work that is going on, what the pod will do or the cluster will do is it will automatically scale and it will create the new pods for the users to access. So this is going to be seamless and pretty super quick, so that users will not even understand what is happening in the background. So this is about scaling. So when we talk about scaling, we have two types of scaling. One is vertical scaling and the other one is horizontal scaling. Okay, so in general, in cloud terminologies, when we say vertical scaling, it is basically adding the resource to the same resource. For example, let's assume that we have a laptop, okay, which has got 0.5 terabytes of memory, but this is not working for the video editing software. So what we will do, we will go ahead and add extra 0.5 TB of memory. So then it is going to work seamlessly. So this is in this scenario, what we did, we added extra resource to the existing resource. That is called as vertical scaling. But in horizontal scaling, what happens? Let's assume the same scenario. We have a laptop with 0.5 terabytes of memory, and we have one more person who is having the same laptop with same TB of memory, 0.5. So what we will do, we will ask him that I will do half of the work and you will do half of the work. Okay, so in this situation, what we did, instead of going with one single laptop, we are using two laptops to complete one particular task. So this is called as horizontal scaling. And if two of the laptop is not sufficient, we will add one more. If this third one is not sufficient, we will add one more. This is called as horizontal scaling. I hope that is clear to you with the theory part. So now what we will do is we will go ahead and create the replica set, and we will try to explore different options that we have with the replica set. So if that is clear to you, let's go on to the terminal and see how to create the replica set. Thank you. All right, folks. So what I've done is I've created a simple replica set YAML file that is required in order to create a replica set. So these are all the required properties. If you see here, I'm specifying API version as apps/v1. That is the parameter that we need to use. And the kind, we are actually creating replica set, so we need to mention that as replica set. And the metadata, I am providing the name as AMCRS, and the labels, I'm just defining the app name as AMC. And also, as I told you, we can define the replicas in the same YAML file, and that comes under spec. Okay, I'm mentioning that replicas 3. So whenever I create this replica set, I'll get 3 pods running at any given point of time, right? If, for example, due to some reason one of the pod crashes, then what will happen is it will automatically create a new one. So again, as I told you, we talked about labels and selectors. So it is going to select all the pods that are named as AMC. Okay, so application name AMC. And template, we are using it from the pod template actually. So from metadata, whatever you have in the pod definition file, go ahead and use it. So I'm using the labels as app here. So make sure that whatever the labels that you have here, it should match with here, because the pods are going to be in the replica set, so it needs to match. And the specs here, what we are mentioning, it is the spec of your pod, not your replica set. Okay, so here I'm mentioning the containers. So the name of the container is AMC, and image, I'm getting it from my own Docker image. So this is the image. Okay, so what I'll do is I'll just Control A and Control C. I'll go here. Okay, so let me clear the screen for you. And what I'll do is I'll just say VI, and I'll say AMC-rs.yaml. Okay, and I'll just go and paste the content that I just copied, and I'll say escape:\wq, write and quit, and that's all. So now we have a file called AMC-rs. So if you want to create the replica set, what you need to do is you need to write kubectl. Let's type the same command again, kubectl create. There is no imperative command to create the replica set. So what we will do is kubectl create -s, and from the name from the file name called AMC rs.yaml, -f for specifying the file name. Okay, so if I hit enter, the replica set will be created for you. So let's give it a moment and see if the replica set is created or not. If you see here, we have a replica set with the name AMC-rs that is already created. So in order for you to view the replica set, what you can do is kubectl get rs, which is the alias for replica set. You can actually expand it, type replica set or mention rs. So I'll go with the simple one. And if you see here, we have the desired count as 3, current as 3, and the ready is 3. Meaning, so you have 3 pods running for you at any given point of time, because that is what we have mentioned in the replicas section of the YAML definition file. So what we can do is, now let's go ahead and check the number of pods that are running. kubectl get pods. So if you see, there will be 3 pods with the same name AMC, but with a different container name at the end. And if you see here, these are all running for you, right? So if you want to access it, again, as I told you, you need to create a load balancer, or you can create a node port and you can try to access that. So we will talk about that later. But if you want to get more details about the replica set, what we can do is, I'll clear the screen. So we have a command called kubectl describe rs, and replica set name was AMC-rs. So if you type this command, it will give you more details about your replica set. If you see here, the name is AMC-rs, the namespace, it is in default, and the selector, if you remember, we gave app is equal to AMC. That is going to be our labels as well. The current replicas that we have mentioned is 3, and the desired is also 3. And the status of the pods is 3 running. If anything is waiting, it will show as waiting. When I say waiting, if there is no resource on the particular node, and if the pod needs to be created but there is no space, then it will show as waiting here. Okay, and if there is any pod that has failed, it will show that here all the things are there. So pod template here, if you can see, this is the image that we are using. This is the port, host port, environment, mounts, volumes, all the things will be there in the describe command. So these are the commands that you can use in order to work with the replica set. So that's all I had for this video. I hope you're learning along with me and you're enjoying whatever I'm teaching. If you're liking the content that I'm creating, please consider subscribing and share it with your friends. Thank you, and I will see you in the next video.